Finding the derivative of y is equal to 1 plus sin x over 1 plus cos x squared. To find the derivative of this function, we need to use the chain rule formula. Therefore, our x is 1 plus sin x over 1 plus cos x. Since we will use chain rule formula, we will bring down this square to the left side and we will minus 1 the exponent. And then we will have the derivative of the x. Then y prime is equals to 2 quantity 1 plus sin x over 1 plus cos x multiplied by 1 plus cos x. Then we will use quotient rule. And the derivative of trigonometric functions. Since using the quotient rule, we know that the low is the 1 plus cos x and the high is 1 plus sin x. We will copy the low, which is 1 plus cos x, and then we will find the derivative of 1 plus sin x. And in the given formula in the right side, we know that the derivative of sin x is equal to cos x. Then minus 1 plus sin x, since we just copy the high from the quotient rule. And then the derivative of the low, which is 1 plus cos x. And the derivative of 1 is 0. Therefore, the derivative of cos x is negative sin x over the quantity of 1 plus cos x quantity squared. Cos x plus cos square x plus sin square x is the result of the multiplication of the given above. Then we will use the Pythagorean identities, which is equivalent to sin square theta plus cos square theta is equal to 1. Since we have the same value as cos squared x and sin square x, then they will be equal to 1. Therefore, we will have y prime is equal to 2 quantity 1 plus sin x over 1 plus cos x times cos x plus 1 plus sin x over quantity 1 plus cos x squared. And we can simplify this since they have both. Therefore, we can simplify this equation since they have both denominator. We will just copy the numerator and we will times the denominator. Then we will have y prime is equal to 2 times 1 plus sin x times cos x plus 1 plus sin x over quantity 1 plus cos x cubed. It is cubed since we times 1 plus cos x to 1 plus cos x squared. Finding the derivative of y is equal to natural log cos x. Therefore, we will use the derivatives of logarithmic function. And our u in this equation is cos x. Then based on the equation that we had, log subscript a u is equal to du over dx is over u ln a. And we will have y prime is equal to negative sin x since the derivative of cos x is negative sin x. Then we will just copy the cos x to the denominator and we will place ln 10. Since it has no subscript, therefore its default is 10. And then we will use quotient identities in trigonometric function, which is sin over cos is equal to tan. Therefore, we can rewrite this as y prime is equal to negative tan over ln 10. find the second derivative, we will use the ln u is equal to du over dx over u. And the quotient rule, which is the low-high minus high-low over lower squared. Y prime is equal to ln 10 and times the derivative of negative tan minus negative tan times the derivative of ln 10 over ln 10 quantity squared. And then we will get ln 10 is negative secant square x minus negative tan times 0 over 10. It is negative secant square x since the derivative of tan x is equal to secant square x. And it became 0 since the derivative of the ln 10 is 0 over 10. And if we multiply it to negative tan, it will be 0. Therefore, we will have second to the derivative is equal to ln 10 times negative secant square x over ln 10 quantity square. Therefore, we can more simplify this by cancelling out the ln 10 from numerator and denominator. And then we will have y to the second derivative of y is equal to negative secant square over ln 10. Find the derivative of x is equal to hyperbolic cosecant 1 over t. We will use the derivative of hyperbolic function that equals to the derivative of hyperbolic cosecant u is equal to negative hyperbolic cosecant u hyperbolic cotangent u times the derivative of u. The u in this problem is the 1 over t. The derivative will be x prime is equal to negative hyperbolic cosecant 1 over t since our u is 1 over t and the negative cosecant is in the formula that was given in that. And the hyperbolic cotangent 1 over t. Therefore, we will use quotient rule since the u is 1 over t. And we will have t times quantity of the derivative of 1 minus quantity 1 times the derivative of t over t squared. Since the high in u is 1 and the low in u is t. Then we will have x prime is equal to negative hyperbolic cosecant 1 over t hyperbolic cotangent 1 over t times negative 1 over t squared. Because the derivative of 1 is 0. 0 times t is 0. And the derivative of t is 1. 1 times 1 is 1 times the negative sign. Negative 1 over t squared. And we can more simplify this. X prime is equal to negative hyperbolic cosecant 1 over t hyperbolic cotangent 1 over t squared. That's all. Thank you.